gentlemen, and welcome to our topic, integration, which is our last topic in the Form 4 Maths syllabus. This topic is not new, and I want to assure you that it is one of the easiest topics in this world, because it is borrowing heavily from topics that we have covered in the past. One of these topics we did in Form 2, called gradients and equations of straight lines. Topic number 2 that we did in Form 3 was graphical methods. And topic number 4 that we did in Form 4 is differentiation. So this topic is going to borrow heavily from these 3 topics, among others. And I just want us to start straight away. Integration is called reverse differentiation, because when we do integration, we reverse the process that we go through when we are doing differentiation. In differentiation, we get the derived function, that is dy dx, if you can remember, from a function. I want us to note that in differentiation, we get a derived function from a function. And our derived function is called dy dx. You can remember very well from differentiation, dy dx. In integration, we get back to that function. We get back to the function from the derived function, meaning that we are given dy dx and we revert back to the original function. That is integration. I want us to consider some linear functions here. Just look at them. We have y is equal to 3x plus 6, y is equal to 3x, and y is equal to 3x minus 3. There are a few things I want us to observe from this. And this is going to borrow heavily from a topic in Form 2 called linear gradients and equations of straight lines. If you look at these 3 equations, if drawn, they are all graphs of straight lines. And all the 3 lines, if drawn, have a gradient of 3 that you can see from the coefficient of x. Each of them has a gradient of 3, you can see. We can therefore say that dy dx for each of these functions is 3. And remember, I said that this topic is going to borrow heavily from differentiation. And in differentiation, we were able to get gradient functions from these functions. And in differentiation, we said that the derivative of a constant is 0. So you can see from all this, the derivative of 6 will be 0. The constant here is 0, so the derivative will be 0. The constant here is -3, so the derivative will be 0. So our dy dx for each of these 3 functions is 3. What you can notice from the 3 lines is that all the 3 lines have different y-intercepts. You can see the first one has a y-intercept of 6. The second one has a y-intercept of 0. The third one has a y-intercept of -3. Meaning that if these 3 lines are drawn, Then they will cross the y-axis at 3 different points. 3 different points. The first one will cross at 6, the next one at 0, and then the next one at -3. What I want us to know is, with a gradient of 3, we can draw more than these 3 lines. We can draw so many parallel lines, just depending on their y-intercepts. We can draw several lines, and that is why I'm noting here that an infinite number of lines can be drawn from a gradient of 3, depending on the y-intercept of each line. I want you to think about that. Straight lines have constant gradients, so these 3 have a constant gradient of 3, but we can have several other straight lines with different intercepts, but having the same gradient of 3. Getting back to the function, given that dy dx is equal to 3, we must now consider the general form of the equation of a straight line, which is y is equal to mx plus c. You remember in Form 2, as we're looking at gradients and equations of straight line, this is a general form that we talk about so much, where m represents the gradient, and our gradient is 3. So if we were to substitute, then it means that the general form of the function from which we had this gradient function is y is equal to 3x plus c. Just remember that I've said, for a gradient of 3, we can have several lines drawn, depending on the value of c that each of the lines has. The 3 lines that we talked about have c's of 6, 0, and -3. But there can be other values of c. So y is equal to 3x plus c, where c is a constant that can take any value, is therefore the general function from which we got a derived function of 3. Remember, when we were in Form 3, looking at graphical methods, we said that gradient is not always constant. For the first case that we have looked at, you can see that it was a constant gradient of 3 because those were functions of straight lines. So we have a gradient of 3. Suppose our dy dx is now 2x. That cannot come from a constant gradient. It can come from a function that could be a curve. Then that means that 2x as a derived function may have come from a function of the form y is equal to x squared plus c. I want you to look at it. If you are to differentiate y is equal to x squared plus c, the process of differentiation is known. You multiply by that power, we'll therefore have 2x, and subtract 1 from that power, we'll therefore have 2x. When you go to c, which is a constant, you will remember that the derivative of a constant is 0. So our dy dx will be equal to 2x, which you can see here. So it means that our 2x may have come from a function of the form y is equal to x squared plus c, where c is a constant. This process that we are going through, where we are saying we are getting a general function from a derived function, is what we call integration. And that is why we are saying that the process of finding functions from a gradient function is integration. To get it, we reverse the rule of differentiation. Now look at this, our table. I just want to bring out the difference between differentiation and integration In differentiation, the first step we had was multiplying each term of the function by the power. The second step was subtracting 1 from the power of each term of the function. When you go to integration, we reverse that process. We now start by adding 1 to the power of each term of the function. And the last step is dividing each term of the function by the power. That here, that if dy dx is equal to x to power n, just a function having one term, then this is what you do in integration. We have y is equal to x. That power was n, so we add 1, n plus 1. We divide by the new power, which is n plus 1, plus a constant. That is the general rule for integration. And in our next class, we are going to look at how to apply it in solving some problems. Thank you, and meet you in the next class.